Suppose that a dice rolled once. Let's start by finding the probability that you roll a 3. Now, this is nothing new. We have been doing this for a few weeks now. So the probability of rolling a 3 is 1 out of 6. There are 6 possible outcomes, and only one of them is a 3. Now, let's suppose that you know you're gonna roll an odd number. So now the possible outcomes would be either 1 or 3 or a 5. So these are the only odd numbers from 1 through 6. If you know that you're gonna roll an odd number, then the probability that you roll a 3, so probability you roll a 3 given odd number, it's gonna be 1 out of 3 now, because there are only 3 possible outcomes. So this is the idea of the conditional probability. You know certain information about the events prior, and then you use that information to find the probability of certain other event. Okay, so now that we have some idea about that, let's talk about conditional probability. The way we denote conditional probability is by writing probability A and a vertical bar B, and this should be read as probability A given B. So in other words, we know about the event B, and we're interested in finding the probability of event A given B. So it's just like the last example we saw, probability of getting a 3 given it's an odd number. And there's a formula for this. So probability of A given B is given by probability of A and B divided by the probability of B. So the numerator is the probability that both A and B happen at the same time. Then we divide this by the probability of B. So this is the formula for the conditional probability. So let's apply this formula to the problem that we saw first. Determine the probability of rolling a 3 given that you roll an odd number. So we'll start with finding the individual probability. So the probability of getting a 3 obviously is 1/6, and probability of getting an odd number is, well, there are 3 odd numbers that you could get, so it's 3 out of 6 or 1/2. So the probability that you get a 3 given, you know, it is an odd number, is going to be equal to, now using the formula, the numerator is probability of getting a 3 and odd number divided by the probability of getting an odd number. So think of 3 as an A, odd number as a B, so this is the same as the formula we had. Probability of A given B is probability of A and B divided by probability of B. Okay, so probability of getting a 3 and an odd number is the same as the probability of getting a 3, because 3 is an odd number, so it is going to be 1/6, same as what we got up here. And then the probability of getting an odd number, well, it was 1/2. Now we just need to simplify this. So we have a fraction dividing a fraction, which is same as multiplying by the reciprocal of the denominator. So it's 1/6 times reciprocal of 1/2 is 2/1. which is 2/6, right? 1 times 2 is 2, 6 times 1 is 6, and 2/6 is the same as 1/3. Notice that this matches with the original answer that we got in that last example, and which it should. Okay, all right, so now that we have some idea about the conditional probabilities, let's take a look at a little bit more involved example. So here in a city, 65% of the families own a car. So I'm gonna record that by writing probability of own a car. So that's a probability of owning a car, and it's given to be 65%, which we're going to write as a decimal 0.65. Now also 45% of the families own a house and a car, so that is the probability of own a house and own a car. So both of those things are happening, and it is 45%, so it's 0.45. Now the question is asking what is the probability that a family owns a house given that family owns a car. So we want to know the probability of owning a house given that you already own a car. And the formula says that this is the same as the probability of own a house and a car divided by the probability that you own a car. Okay, so this is going to be equal to, so probability of owning a house and a car, we're given that information is 0.45 divided by probability of owning a car was 0.65. And at this point you use a calculator and get your final answer. So this is the probability that the family owns a house given that the family owns a car. This is it for the conditional probability.